Hi, this is Yuri from Tracelabs, and I'm going to give you a quick demo of our application for automated milk payments powered by the network operating system. Now, dairy supply chains are very complex, and they involve many stakeholders going from farmers, cooperatives, dairies, and dairy laboratories. And this complexity is also reflected in the contractual landscape between these different parties, particularly with payments to farmers for the provided milk. This is because milk price is usually determined by multiple factors like volume, milk quality, which is often expressed in protein and fat contents, as well as negotiated rates. And these contractual arrangements and the associated calculations for payments are often very paper-based, done manually, and therefore very inefficient and prone to error. The automated dairy payments application, powered by Tracelabs' NOS, provides an efficient and secure way of automating these payment transactions, utilizing, on the one hand, the OriginTrail Decentralized Network as a trusted oracle that stores linked data on milk volumes and milk quality that originate from different multiple data sources. And on the other hand, the Oracle blockchain platform and Hyperledger Fabric blockchain, providing the smart contract framework that holds private contractual terms and performs payment calculations based on trusted data from the OriginTrail Decentralized Network. Now, we'll be showcasing this demo through the eyes of a dairy cooperative, and jumping right into it, here we are at the automated dairy milk payment application screen, and here is the section where we actually upload the milk batch volume information, which is here. So this gives us information, this is an example CSV file that gives us information on the milk batches and volumes that the farmers provided. And here is an example file that we would receive from a laboratory that actually contains information on milk quality for those batches of milk, which is key to calculating the price. Now, we're going to upload both of these files through this interface in the NOS. And what's going to happen is that the NOS will make these datasets interoperable, utilizing the GS1 EPCIS and the W3C verifiable credentials data models before we actually then publish these datasets to the OriginTrail Decentralized Network. Now, we're doing this here in this demo manually, but data can also be shared from legacy systems via email or ideally via the NOS API, which really then enables that full system interoperability and automation. Now, we've uploaded these two files. The NOS will make them interoperable, as mentioned, according to these standards, and let's have a quick look. So these are the two files that we've uploaded, and we can actually have a quick glance at how the structured output files look like. This is the file containing the laboratory test results. So here we can see for each batch of milk, we can see the results in terms of protein contents and fat contents. And we can also have a look at the APCIS XML that contains structured information around the volumes that the farmers provided and the associated batch numbers of those particular milk deliveries. So if we now actually publish these data sets to the OriginTrail Decentralized Network, this will take a little bit of time, but let's just go through this. Okay, now that we have published both of the data sets to the OriginTrail Decentralized Network, they can be linked and serve as trusted data input. But let's just have a quick look at one of the batches of milk that we can query on the actual OriginTrail network to see that they have actually been published. So I'm going to go to the OriginTrail Network Explorer and just quickly query for one of the identifiers I just took out of one of the milk batch identifiers that I just took out of the dataset we published. We're going to query for it and just check that the dataset is actually there. Okay, now that the query has run, we can actually see that the dataset with milk batch and volume information has been replicated on the OriginTrail Decentralized Network. We can just quickly have a look at how this looks like, how this dataset looks like once it's replicated. So there we go. So we can see the data here, and we can actually have a quick search for the identifier that we took from XML file in NOS, and we can see that we have the information around that particular batch of milk available on the decentralized network, and it will be linked to the quality results from the laboratory results file. So going back to the NOS, we now have a quick look at the rate card itself. Now, this rate card is really the rate per liter of milk that the dairy pays the cooperative based on the quality parameters, and in our case that will be the percentage of fat and percentage of protein that are provided by the dairy laboratory themselves. And this contractual rate is actually stored in the Oracle blockchain platform Hyperledger Fabric smart contract, and changing the rate here in the NOS interface is reflected there directly. Now, for the purpose of this demo, we'll change the rate and see how the transaction actually is reflected in the Oracle blockchain platform. So let's have a quick change here and say, let's move this from 0.1 to 0.2. And we will change this one from 0.2 to 0.3. We're going to apply the changes, and as we apply the changes, this is actually being reflected or changed in the appropriate smart contract on the Oracle blockchain platform. And let's have a look at how this actually looks once it's done. So I'll just quickly refresh here, and we can actually see that there is a transaction here, block. We can have a look, and we can look at the transaction itself and see that the protein rate actually was changed to 0.3 and the fat rate to 0.2, which is what we have just done in the network operating system. And here in the Oracle blockchain platform console, this is now almost immediately reflected in the appropriate Hyperledger Fabric smart contract. So this is how that interaction between the Oracle blockchain platform and the NOS looks like. Going back to the NOS and to the automated milk payment application, a quick word on the rate card setting that we just looked at as well, which is important in this demo. We changed this directly as a cooperative, but depending on the specific requirements of the involved parties, a required confirmation from multiple sides could be set up. For example, that any change would need to be confirmed by the cooperative and the dairy as contractual terms between them change. But for the purpose of this demo, we changed this as from the perspective of a cooperative, just to demonstrate how everything runs. Moving on to the farmer overview. In this section, we can really see a list of all farmers that are providing milk to the cooperative and their negotiated margins. So this is, you can see the farmers here and the negotiated margins here. And this is really the percentage that the cooperative actually charges the farmer for selling the milk to the dairy. And it needs to be taken into account, of course, when calculating the final payments to the farmers. Now, the milk volume and quality files that we published to the OriginTrail Decentralized Network in the previous steps will be linked to the relevant farmers and margins we see here. And these contractual parameters are also stored in the Oracle blockchain platform Hyperledger Fabric smart contract. And the cooperative can easily update the list when new contracts are negotiated directly in this interface. All of these updates are executed as transactions on the blockchain transparently and are auditable by Oracle blockchain platform instance users. And updating this list would actually result in a similar transaction on the Oracle blockchain platform as we saw in the previous step. But for the purpose of this demo, we won't be updating the list. That's the farmer overview, and moving on to the final step, which is generating the actual payment file, which is really taking all of the input that we went through in the previous steps. We can actually now generate a payment file for a specific month. In our case, that month will be May. And we will run the calculation, which will be done by the Oracle blockchain platform Hyperledger smart contract. And it will take into account the milk volume, the milk quality data that are stored on the OriginTrail Decentralized Network, as well as the contractual parameters which are stored in the Hyperledger Fabric smart contract. Now I'm going to generate this file, and as it's generating, one note here is that in this demo the payment file is an Excel document, but depending on the specific requirements, this can be easily adjusted. So let's have a quick look at the payment file result here. So this is how then the payment file result looks like. So we can see actually all of the milk batch IDs here. We can see what the volumes were in those batches. We can see the test results, and we can see the total payments that first the cooperative actually gets, what is the margin that they take, and what is the amount that needs to be transferred to the farmers in the end. And in this case, this is an Excel file, but this can be very, very easily adjusted. For example, a SEPA file, payment file could be generated and pushed directly to financial modules in an ERP system where they could wait just final approval and automatic payment execution. So this is really just a way having a different way of output depending on different requirements of each stakeholder in the supply chain, or different cooperatives across different supply chains. And really then having this combination and combining the power of OriginTrail Decentralized Network that serves as a trusted oracle for milk volume and quality data, and Oracle blockchain platform Hyperledger Fabric that provides the private smart contract framework to hold private contractual terms, the automated dairy payments application really not only increases the efficiency and transparency of the payment process in the dairy industry, but also provides data integrity and interoperability that can be then used and expanded on in a broader supply chain context for potential other uses as well. Thank you very much. This has been the quick intro into the automated milk payment application by Trace Labs, powered by the network operating system.